Imagine a traveler with no weight to hold it down, no mass, no substance to push or pull. A traveler that does not need to accelerate because it is born already at the fastest possible speed the universe allows. It leaves the moment it comes into existence, and it never slows. This traveler is light. To the human eye, light seems ordinary. We walk through it every day. We flip a switch and fill a room with it. We watch it reflect off surfaces, scatter through mist, or vanish when it hits something dark. Yet light itself never touches anything. It transfers energy, it carries momentum, but it does not collide the way normal matter collides. It simply moves. Every second it crosses almost 300 million meters of space. That is a distance so great that if the Earth were a perfect circle, light could travel around it 7 times in a single second. No jet, no rocket, not even a ship powered by antimatter could ever keep up with it. You could push your vehicle until the engines melted into plasma, but you would still crawl compared to the traveler that crosses empty space effortlessly. Light does not speed up when it leaves a star. It does not slow down when it reaches a distant world. It simply exists at that speed. The moment a photon is created inside the burning heart of a star, it begins a journey. It passes through chaotic layers of fusion and storms of ionized gas. It dodges electrons and atoms, bouncing again and again, until at last it escapes into open space. Once it reaches the void, there is nothing to stop it. There is no air to press against it, no drag, no friction. Most waves require something to move through. Sound needs air or water. Ripples need a pond or a surface. Light needs nothing. It is a self-carried vibration of electric and magnetic fields. It moves in pure empty space as easily as it passes through the glass of a window. If you held out your hand toward a beam of light, your atoms would never feel it sliding past. Light can be absorbed when matter swallows its energy. It can be reflected when a surface returns its motion. It can be scattered when it interacts with charged particles. But light is never touched. The photon does not rub against atoms the way matter does. It does not experience friction or drag. Nothing ever slows it by contact. It is a perfect traveler that simply continues. This idea seems impossible. Every force we experience depends on pushing or pulling. You feel the ground press against your feet. A ball bounces because it strikes a surface. Even gravity, as we feel it, seems like an invisible pull that acts on things with mass. If light has no mass, why should it be influenced by anything at all? Under the classical view of gravity, that question had an easy answer. In the age of Isaac Newton, gravity was imagined as a pulling force. A massive object would tug on anything with mass. No mass meant nothing for gravity to pull. In that old picture, light should have been completely unaffected by gravity. It should have sailed in a perfect straight path, no matter what it passed. Reality disagreed. Starlight passing near our sun shifts its path. Photographs taken during a solar eclipse in the year 1919 revealed that light arriving from distant stars appeared in slightly different positions. It was not the stars that changed. It was the path of their light. The traveler was deflected, even though gravity could not touch it. Something far deeper was happening. Light obeys no force in the usual way. Instead, it obeys geometry itself. It always follows the straightest possible path through space-time, straight through what appears to be empty space. But what if space is not flat? What if it can bend? If the fabric of space curves, then the straightest path through that curved shape will appear bent to us. Light does not curve. Space curves and light simply follows. In a way, the photon behaves like a marble rolling on a sheet. If the sheet is flat, the marble moves straight. If the sheet is dipped into a valley, the marble travels along the curve. You never touch the marble. You change the sheet under it. Gravity does not pull on light. Gravity warps the stage on which light travels. The traveler remains free, but the path changes. Light is the witness of the universe. It carries the image of galaxies that lived billions of years ago. When we look into deep space, we do not see distance, we see time. Photons that left their stars when Earth was still molten arrive in our telescopes today. Some of those photons traveled across distances measured not in trillions of kilometers, but in numbers so large that only words like 10 to the power of 20 or 10 to the power of 30 can describe them. And yet they never slowed. They never drifted off their path. They followed the shape of space perfectly. We are surrounded by this silent traveler. Every sunrise, every reflection in a window, every pin of light in the night sky is a story carried across the structure of space-time itself. And because light always follows the true geometry of space, it reveals the hidden shape of gravity. Wherever light bends, space bends. Wherever space bends, gravity acts. Light shows us the invisible. The traveler moves freely, but the map beneath it can change. Light does not experience time the way matter does. For us, a journey takes seconds or hours or years. For light, the entire trip from one end of the universe to the other happens with no passage of time at all in the reference frame of the photon. From its perspective, the moment it is born and the moment it is absorbed are the same moment. This creates a strange tension between what we feel and what light experiences. We speak of speed as distance divided by time. But for something that never experiences time, speed becomes something deeper. It becomes a property locked into the architecture of existence itself. We say that nothing can move faster than light, but the full meaning of that rule is stranger. It is not just that nothing can outrun it. It is that nothing with mass can even reach its speed, because reaching that speed would require infinite energy. The traveler needs no engine. It needs no fuel. It is pure motion, pure momentum. And because it has no mass, it never slows down, not in perfect vacuum. Only when light enters matter does it appear to slow. But this is an illusion. The photon is still traveling at its universal speed between atoms. It simply interacts with the atoms in the material, being absorbed and re-emitted again and again, causing the average progress through the material to be slower. It is like a runner who sprints constantly, but must stop to check every doorway along a hallway. The runner never slows, but the hallway makes the journey take longer. When photons leave that hallway and return to open space, they are free once more. Every moment of travel is the shortest possible path through space-time. Scientists call this path a geodesic. The word feels complex, yet the meaning is simple. It is the straightest possible line, even if the space it travels through is not flat. On a sphere, the straightest path appears curved. A plane flying across the Earth follows a curved line on a map, but a straight line over the surface of the world. If the surface itself is curved, then straight lines bend. This is why the ancient idea that gravity pulls on light was never correct. Gravity does not reach out to grab. Gravity reshapes space. Imagine walking across a valley. If the ground curves down, you descend without being pushed. If the ground curves up, you climb without being pulled. Gravity is the landscape. Light is the traveler moving on that landscape. When Albert Einstein introduced the idea that mass and energy tell space-time how to curve, he erased the last remaining mystery about why light changes direction around massive objects. Light has no mass, but space-time responds to everything that carries energy, and light carries energy. Even a single photon carries momentum, not because of mass, but because of its motion. When you turn your face toward the sun and feel warmth, you are feeling the energy of countless photons that have crossed 150 million kilometers of empty space and finally gave their energy to your skin. Yet none of those photons ever touched you. They ceased to exist the instant their energy was absorbed. It is this strange property that makes light both fragile and unbound. A photon is destroyed the moment matter claims its energy. A photon cannot rest or wait. It either moves or ends. There is no in-between. To exist is to travel. To stop is to disappear. On the surface, that seems tragic, as though light lives only to die. But without this behavior, there would be no photosynthesis. Plants on Earth convert the energy of sunlight into the chemical energy that feeds nearly all life on this world. Without that conversion, every forest and every blade of grass would vanish. The single photon born inside our sun might spend tens of thousands of years bouncing through layers of dense plasma before escaping to space. Once free, it may travel for 8 minutes until it reaches Earth. Then, in less than a trillionth of a second, a plant absorbs it and transforms it into life. Light is everywhere, yet each photon exists only once. Even more astonishing, every photon travels in silence. It carries information from distant galaxies, crossing distances that no spacecraft could ever hope to cross. When we observe faraway galaxies, we are not seeing where they are, we are seeing where they were. A galaxy that appears today might have sent that light when our planet was still a molten ocean of stone. The further we look, the farther back in time we see. Light does not just illuminate space, it reveals history. The deeper we observe the cosmos, the farther into time we peer. Light is a time machine that only moves forward. We depend on light to understand the universe, yet we barely grasp its strangeness. It behaves like a wave, but it arrives as a particle. It carries momentum, but it has no mass. It moves in straight lines, yet can curve when space itself bends. It does not feel time, yet it shows us time. When light passes near a massive object, its path changes because the geometry around it is altered. What appears to be a bend in the path is simply light following the true straight line through curved space-time. In the year 1919, this idea moved from theory to proof when photographs from the Eclipse expedition showed that starlight shifted positions as it passed close to our sun. The effect was tiny, but real. The universe itself had spoken. Space can curve. Light obeys that curvature. The experiment shook the foundations of physics. It meant that reality was not a rigid stage. The stage itself could stretch, curve, and fold. Light traveled across that ever-changing stage, bound not by force, but by geometry. The traveler was free, but the map beneath it could be rewritten by anything with mass or energy. Light reveals the universe by refusing to stop. Every photon is a witness to distance and time. When we look into the night sky, we are seeing messages that left their origin long before the first human existed. The light of many stars that we see tonight began its journey when giant reptiles walked across continents that have since drifted apart. The light of certain distant galaxies began its motion before the Earth itself formed. Those galaxies may not even exist anymore. The last proof of their existence may be arriving in our telescopes at this moment. We do not perceive how powerful this is. Light does not simply travel through the universe. It records the universe. It carries the memory of distant places frozen into its motion. It follows the shape of space-time perfectly. It cannot choose to leave the straightest possible path. It cannot decide to stop. It cannot turn around. It has no free will and no hesitation. It is pure commitment in motion. And yet this perfect traveler, which ignores every force that acts through contact, reacts to gravity without ever being touched. To understand that, you must imagine a world made not of empty volume, but of structure. Imagine walking across a huge field of fabric that stretches in every direction. If something heavy rests on the fabric, the surface sinks around it. If you walk nearby, the curve of the fabric redirects your path. You are not pushed. You are guided. Your steps still follow the straightest possible path over the curved surface. This is what light experiences. A star or planet does not pull on light. It changes the shape of space itself. The first people to realize this were exploring with mathematics rather than telescopes. They tried to describe how light should behave if space-time had a shape that could bend or stretch. They discovered that if mass or energy is present, then space-time is not flat. It is curved. They did not imagine a force reaching outward. They imagined geometry changing inward. Once this idea was understood, the consequences became astonishing. If you place enough mass into a small enough region, the curvature of space-time becomes so intense that every straight line through that region points inward. Even light is forced to follow those lines. Not because light is pulled, because the direction that defines forward no longer leads outward. The path itself collapses inward. Pure geometry traps the traveler. We usually imagine the universe from the viewpoint of matter. We use our bodies as the baseline for time. We use our legs as the baseline for movement. We think mass gives authority, but in the deepest sense, the photon holds truth. It does not hesitate or judge. It simply follows the structure of space-time. Every photon traces the exact path the universe allows. A photon can leave a star and travel for 10 to the power of 10 years without interacting with anything. It may pass through entire galaxies without ever touching a single atom. The space between stars is unimaginably empty. If the sun were a sphere the size of a basketball and Earth were a pebble, about 26 meters away, the nearest star would be placed on the opposite side of Earth. Most of the universe is not filled with matter, it is filled with absence. Yet that emptiness has shape. Space is not nothing. Space is the stage on which physics plays out, and that stage can be bent. When a massive object like our sun bends space, light obeys that bend. The bending is so subtle that it is invisible to our eyes. Only sensitive instruments can detect the shift, but it is there. It is measurable. It is undeniable. Light taught us that gravity is not a force. The moment we realized that space could bend, we opened a doorway into an entirely different vision of reality. The concept that mass reshapes the fabric of space means the universe is dynamic. Not a cold stage, but a living geometry. The fabric stretches. When the universe expands, it vibrates when gravitational waves pass through. It carries the memory of events from billions of years in the past. Every photon rides those shapes without wasting a single moment of time. It traces the purest possible line. Light does not care about what we believe. It simply reveals what is true. You can think of light as the universe showing itself to us. Every direction we look is a story written by photons that began their journey long before human language existed. The reason we can measure the expansion of the universe is because the wavelength of the light we receive changes as space stretches. The photons themselves do not slow or weaken. The space they travel through becomes larger, and the distance between each crest of the wave becomes longer. Light becomes redder because the universe has grown around it. This property is called redshift. It allows us to measure how quickly distant galaxies move away from us, and it tells us that space itself is expanding. Light does not only record distance, it records motion. It carries the secret of how the universe evolved from a dense and violent beginning into the cosmos we see today. Every law of physics begins with observation. Our ancestors looked into the sky and wondered what stars were made of. They had no idea that the answer would arrive carried on the back of light. When a photon reaches us from a star, its wavelength reveals what atoms are present in that star. It reveals temperature. It reveals motion. A single photon can be a complete report, and we receive uncountable photons every second. The most profound truth is that light has no awareness of the information it carries. It simply travels. Everything else is revealed by our interpretation. Light is unbiased. It never lies. It only moves. At the edge of our vision, there are galaxies whose light has taken more than 13 billion years to reach us. That light began its journey when the first stars ignited in a universe still filled with the leftover glow of the Great Expansion. The photons we detect today have moved through space for nearly the entire history of everything. Not once did they touch anything. Not once did they slow. They are messengers that have crossed a universe whose size we barely comprehend. And all of this leads to one quiet but powerful truth. Light moves freely. Gravity moves space. Light cannot outrun the shape of space. For most of human history, we believed that gravity was a pull, a force reaching across empty space that tugged at anything with mass. We felt it in our bones. We drop a stone and it falls. We leap and we return to the ground. The motion seems so simple that it hides a deeper truth. The stone is not being pulled. The stone is following a path shaped by the space around it. Gravity is not action at a distance. Gravity is geometry. Imagine an enormous stretched sheet that represents space itself. Place a heavy sphere on that sheet. The weight presses into the surface, creating a curved depression. If you roll a marble across the sheet, it will curve toward the sphere. Your instinct is to say that the sphere pulls the marble. But that idea misses the truth. The marble only follows the straightest possible path across the curved surface. Space itself is guiding the motion. You do not need a pull. You only need shape. Albert Einstein asked a question that changed everything. What if gravity is not a force at all? What if space and time are not independent, but part of a single fabric? What if mass and energy tell that fabric how to curve, and curved space-time tells matter how to move? It was a bold idea. It replaced the old world of forces with a world of geometry. The prediction was radical. If space-time can curve, then objects will follow those curves naturally. They will not need to be pulled or pushed. Even a planet orbiting a star is not circling because it is dragged around. It is following the straightest path through curved space-time. The orbit is simply the shape of space. To understand this, stand perfectly still and drop a ball. From the perspective of classical physics, the ball accelerates downward because gravity pulls it. But from the viewpoint of curved space-time, the ball is actually moving in a straight line through a warped region. The ground interrupts the motion and pushes against you. You are the one resisting the natural path. The ball is free. You are held in place. This shift in perspective is profound. It means that falling is not motion that requires a force. Falling is the absence of force. Astronauts in orbit around Earth are not floating because gravity has vanished. They are falling freely along the curved path of space-time. The spaceship and the astronauts inside follow the same geodesic, the same straightest path through curved space. No force pulls them inward, only geometry. In this new picture, mass and energy act like sculptors of space-time. A star bends space around it. A planet bends space around it. Even a person bends space by an unimaginably tiny amount. The more mass something has, the deeper the curvature. The deeper the curvature, the stronger the effect we call gravity. The closer you are to the mass, the more pronounced the bending becomes. This is why a planet holds a moon in its motion. The moon is not attached by an invisible rope. The moon travels straight ahead, and space-time curves beneath it. The moon follows that curve the same way a marble follows a groove. The curvature is the orbit. Once you see gravity as shape instead of pull, a remarkable question appears. If space-time can bend a little near a planet, could it bend more near a star? If it can bend strongly near a star, what happens near something far denser? How deep can curvature become? Could space curve so sharply that not even light can escape? The answer to that question leads to black holes. But to reach that destination, we must first understand the nature of straightness itself. We often think that straight means a line that never curves. But straight is not absolute. It depends entirely on the shape of the space through which the path travels. Draw a line across a globe representing Earth. The shortest and straightest line curves across the surface. A pilot flying from one continent to another follows a path that looks curved on a flat map. Yet in reality, it is the true straight line across the curved world. Light follows the same rule. It always takes the straightest possible path. If the universe around it is curved, the path will appear bent. We see this as gravitational lensing. A massive galaxy cluster bends light from galaxies hidden behind it. That bent path allows us to see what would otherwise be invisible. No force touches the light. No hand grabs it. The light is not pulled inward. It simply follows the shortest route across a warped landscape. When Einstein proposed this idea, it was not accepted immediately. It sounded too strange. The idea that space itself has shape was almost unthinkable. The idea that matter could influence that shape was even stranger. But when the solar eclipse of the year 1919 showed that starlight shifted positions as it passed near our sun, the proof became visible. Space is not rigid, it bends. Light shows us the bend. This means that every motion we see, from an apple falling from a tree to a planet orbiting a star, is the same phenomenon. It is the continuous response of matter to geometry. Gravity is not something that acts on matter. Gravity is the result of matter shaping space-time. Gravity shapes reality quietly. We feel it constantly, yet rarely question it. It presses our feet against the ground. It holds the air around our planet. It keeps oceans from drifting into space. We are so used to its presence that we assume it is something simple, something obvious, a force that pulls. But if gravity were truly a pull, light would ignore it completely. Light has no mass, so nothing should tug on it, and yet starlight bends. This bending tells us that gravity is not a force at all. Gravity is the architecture of space-time. To understand the difference, imagine standing at the edge of a vast canyon with a river flowing below. The river is not pushed by an invisible hand. It follows a path carved into the land. The water flows because the land guides it. Gravity acts the same way. It is not a hand that reaches out and pulls objects. It is a shape that guides how objects move. Space-time forms the canyon. Matter and energy are the sculptors. When Einstein wrote the equations that describe this, he discovered something astonishing. Space is not just a background. Time is not just a measure of motion. Together they form a single connected fabric, and that fabric can stretch and curve. Every object that exists, from dust to planets to stars, bends the space-time surrounding it. Even empty space is influenced by energy. When you stand on the surface of Earth, you are not held down by a force. The ground is simply preventing you from taking the natural path through curved space-time. Consider a person floating inside a spacecraft. If the spacecraft is in free fall, that person feels weightless. They are not escaping gravity at all. They are obeying it perfectly. They are following the straightest possible path through space-time. If they let go of a tool, it drifts beside them because both of them are moving along that same path. They are not falling toward Earth. They are moving around Earth. The path curves because space-time curves. Even the sensation of weight has nothing to do with gravity itself. Weight is the force your body feels when something prevents you from following the natural curve of space-time. Stand on the ground and the ground pushes upward on you. That resistance is what you feel as weight. Sit in a chair and the chair presses against you. In free fall, with no resistance, the feeling vanishes. Your body follows the curve of space-time and weight disappears. Once this becomes clear, a strange thought appears. If everything moves along the straightest path through curved space-time, why do different objects fall at the same rate? Why does a hammer and a feather strike the ground together when air is removed? The answer is simple. Every object, regardless of mass or shape, follows the same geometry. Geometry does not care about mass. Geometry defines motion. Gravity is the geometry. This idea also explains why a planet far from its star continues to orbit year after year. There is no need for a force to maintain motion. The planet follows the path carved into space-time by the star. If the star vanished instantly, the space-time around it would smooth out, and the planet would no longer have a curved path to follow. It would not be yanked inward, because nothing was truly pulling it. It would simply travel in a straight line through the now flattened space-time. The more massive an object is, the deeper the curvature it creates. A planet bends space-time. A star bends it far more. A compact object like a neutron star bends it intensely. And a black hole bends it so deeply that all straight paths lead inward. At some point, the geometry becomes so steep that escape becomes impossible. Not because something grabs light, but because the only possible forward direction points down. To escape would require motion faster than the speed of light. Light is already moving at the fastest possible speed. It cannot go faster. The geometry wins. This realization changes how we picture everything. The sun does not hold Earth in place. Earth is not captive. Earth is traveling freely through the shape carved by the mass of the sun. Our entire solar system is a collection of worlds riding the geometry of space-time. The paths of the planets are not controlled by force. They are written by shape. Einstein described this in words that sound almost poetic. Mass tells space-time how to curve. Curved space-time tells matter how to move. That is gravity. Nothing more, nothing less. A conversation between existence and motion. Some ideas take time to settle into the mind. We are so used to thinking of straight lines as obvious that we forget straightness is defined by the environment. Walk across a flat field and your path seems simple. Walk across a mountain and the straightest route becomes a climb and a descent. The mountain determines your motion. The universe behaves the same way. If space-time were perfectly flat everywhere, objects would move in perfect straight lines forever. But space-time is not flat. It is shaped by everything within it, and light, matter, energy, and time all follow that shape. This is why gravitational waves exist. Think of space-time as a sea. When massive objects accelerate, such as two black holes spiraling together, they send ripples across the sea of space-time. These ripples travel at the speed of light. They stretch and compress the distance between objects as they pass. We cannot see them with our eyes. We detect them with precise instruments that measure tiny changes in length, smaller than the width of a single atom. When these ripples were detected for the first time, we were not observing a force. We were observing motion in the fabric of reality itself. Gravity is not an external player acting upon the universe. Gravity is the universe. The deeper we explore gravity, the stranger it becomes. If mass reshapes space-time, then energy must do the same. Light carries energy. Radiation carries energy. Even pressure carries energy. Anything that has energy changes the shape of space-time. This means that the empty space around a star is not truly empty. It is shaped by the presence of mass at its center. But the star also radiates light. That radiation carries energy outward. As it leaves, it slightly alters the curvature around the star. Space does not simply respond to mass. It responds to anything that influences the geometry. Once you truly accept this, the universe transforms in your mind. You no longer picture planets moving in circles as prisoners of a pulling force. You picture them as travelers gliding across a curved landscape. The landscape is invisible, but its effects are undeniable. A spaceship passing near Earth will have its trajectory curved even if its engines are off. It follows the same rule as the Moon. The spacecraft is not pulled, it is guided. The astronaut inside may feel weightless, but every moment of motion still obeys the shape of space-time. Even time itself is bound to gravity. Time flows differently depending on how strongly space-time is curved. If you stand at sea level, time passes ever so slightly slower for you than for someone standing on a mountain. The difference is tiny. But satellites orbiting Earth must account for it. Without adjusting for the difference in the flow of time caused by Earth's gravity, global positioning systems would drift off course by many kilometers every day. Technology that guides aircraft and ships and emergency services functions correctly because we adjust for the fact that time does not pass at one universal rate. Time is part of the fabric. If the fabric bends, time bends with it. Space-time is not a stage upon which events unfold. It is the event. Think of a trampoline. Place a bowling ball on it. Roll a marble nearby. The marble curves inward. If you spin the marble with the right speed, it will orbit the bowling ball. If you give it too little speed, it will spiral inward. If you give it too much, it will escape. But in no case does the bowling ball pull the marble. The fabric guides the motion. Now imagine replacing the trampoline with space-time, the marble with a planet, and the bowling ball with a star. Gravity is not a force. Gravity is the shape of the fabric. When we look up at night and watch stars shimmer across the sky, we are seeing light that has followed geodesics, the straightest possible paths across the curved universe. Galaxies bend light around them the same way glass bends light here on Earth. This bending allows us to see galaxies that would otherwise be hidden. We call this gravitational lensing. A cluster of galaxies can act as a cosmic magnifying glass. It stretches and distorts the path of light, revealing distant objects. We would never know those distant objects existed without the bending of space-time. The more massive the cluster, the stronger the lensing effect. Light arriving at our telescopes tells us how much matter is present. It tells us how space-time has been shaped. In this way, light becomes a tool for measuring gravity itself. We map the invisible by watching the path of the visible. Gravity does not interact with light. Gravity interacts with space-time. Light moves through space-time and reveals the shape created by matter. This is why scientists can detect invisible matter we call dark matter. We cannot see it directly because it does not interact with light, but we see how light bends around it. The bending reveals mass that should not be there. Without gravitational lensing, dark matter would remain a theory. With lensing, the shape of space-time becomes a map showing that unseen mass is exerting influence. Light exposes what the eye cannot. Everything moves freely until the geometry demands a change in direction. Space curves, time stretches, motion follows. There is a deeper implication. If space-time curves, then curvature can become extreme. Imagine compressing a star many times larger than our Sun until all its mass is squeezed into a sphere no larger than a city. The curvature becomes intense. Space folds inward and time slows dramatically. Light passing near such an object bends sharply. Now imagine compressing even more mass into an even smaller region. At some point, the curvature becomes so intense that every forward direction leads inward. This is where a black hole forms. Not a hole in space, but a place where geometry becomes so steep that the path of escape disappears. Not even light, the fastest traveler in the universe, can find a direction that leads outward. Not because something pulls it, but because space-time no longer offers a way out. All possible paths lead only inward. A black hole is not an object waiting to consume. It is geometry collapsing into inevitability. We have not reached that chapter yet, but gravity is already pointing us toward this conclusion. If geometry can guide matter gently, it can also trap matter completely. If space-time can bend a little, it can bend without limit. We cannot stop the curve once enough mass gathers in one place. The fabric gives way to the weight of energy pressed into a small volume. At that point, the rules change. Light obeys geometry. Geometry obeys mass. So when mass becomes overwhelming, geometry becomes absolute. This realization leads to a question that seems almost frightening. If gravity shapes space, can space ever become so curved that time itself cannot escape? Could time be trapped just as paths are trapped? Inside a black hole, the answer is yes. Time is forced to move toward the center just as surely as space curves inward. The path is fixed. Forward means downward. Every straight line ends at the singularity, but we are not there yet. We are still in the realm where gravity is gentle enough to feel familiar. We watch leaves fall. We watch rain form arcs. We see tides rise and recede because the moon shapes space-time around Earth. Yet even these simple motions are echoes of the same geometry that reigns around black holes. The same laws apply everywhere. Gravity does not change. Only the intensity of curvature changes. Once we accept that the universe is made of space-time, and space-time is shaped by mass and energy, everything else follows. There is no force field. There are no invisible strings. There is only shape. There is only motion along that shape. The rest is illusion. Most people think space is emptiness, a void where events occur. But space is not empty. Space is structure. Space is flexible. Space responds. Space can vibrate. Gravity is not something inside space. Gravity is what space is doing. At its core, gravity is the silent sculptor of reality. Light travels as though the universe owes it nothing and promises it everything. It moves straight, never slowing, never drifting off course. If nothing interfered, a photon could cross the entire cosmos without ever changing direction. In that perfect freedom, light seems unstoppable. It seems immune to all influence. No contact force touches it. No drag slows it. No friction presses against it. Yet there exists a phenomenon so strange that it appears almost magical to the human eye. Light seems to bend. Stars appear in places they should not be. Galaxies become warped and stretched as though viewed through a sheet of moving water. Rings of light form around distant objects where no ring exists in physical matter. We call these visions gravitational lensing, but the term is misleading. It sounds like a lens that grabs light and bends it. It suggests some force acting directly on the photon. The truth is far more profound. Nothing touches the photon. Nothing grabs it. The space through which the photon travels simply curves, and the photon obeys the curve because it must always follow the straightest possible path through space-time. If space bends, the straightest path bends as well. Imagine walking across an enormous field made of soft clay that curves in subtle hills and valleys. If your goal is to move in a perfectly straight line, your path still rises and falls with the ground beneath you. It feels straight because you are not deviating to the left or right, yet the vertical movement changes because the surface has shape. Light experiences exactly that. It never decides to bend. It never chooses to curve. It simply continues forward, and the universe under it flows. The first evidence of this came from an event that changed the history of science. In the year 1919, during a total solar eclipse, a team of astronomers photographed the night sky in daylight. When they compared the positions of stars near the eclipsed sun to their positions in the night sky, they discovered that the stars appeared shifted. Their light, while passing near the sun, traveled along space-time curved by the sun's mass. The stars themselves never moved. Light moved differently. The prediction that Einstein made was confirmed. Mass does not pull on light. Mass shapes space. Over time, we built instruments that could detect this bending on grand scales. We pointed telescopes not at stars, but at clusters of galaxies. Some galaxy clusters bend so much light that they act like colossal lenses made of space-time. They magnify objects far behind them. Galaxies that should be invisible appear stretched and curved into arcs of light. One of the most striking examples is a system of 4 gleaming points surrounding a central galaxy. It is called the Einstein Cross. The 4 points are not separate stars. They are one distant galaxy whose light has been bent into multiple images. Another example sits in a cluster called Abell 370. There, light from other galaxies forms long, luminous arcs. Nothing is grabbing that light. Space itself is guiding it. To understand how the effect works, imagine that you are peering through a perfectly clean window. If the glass is made with flawless precision, the view appears unchanged. But if the glass has thickness and curve, the deep scene behind it shifts. Objects warp, grow, shrink, and sometimes duplicate. Gravitational lensing is the universe itself acting as a window whose thickness varies across space. The difference is that a lens of glass bends light because atoms inside the glass interact with the photon. A gravitational lens bends light without a single atom touching the photon. Space does all the work. A photon leaving a distant galaxy may travel for 10 to the power of 10 years. During that unimaginable journey through space, it follows the geometry of the universe. When it passes through the gravitational field of a massive cluster, the path curves gently. When it emerges, it continues onward in the new direction. It still believes it is traveling straight. The curvature it experienced is now embedded in the trajectory. Eventually, it reaches Earth, hits a detector in a telescope, and becomes a data point. Watching where the photon appears tells us everything about the shape of space it followed. This bending lets us measure not just visible matter, but invisible matter. When light bends more than it should, we conclude that something massive must be present but unseen. We call this dark matter. We do not know what it is made of. We only know that space-time bends around it. Light reveals what we cannot see. The photon has no mass, yet it maps mass by obeying geometry. This bending effect proves something deeper. Light never slows when traveling through vacuum. The energy may stretch into longer wavelengths if space expands, but the motion never falters. The path is not changed by force. It is changed by shape. Even when a photon seems trapped, even when it circles a massive object, the photon is still following the rule that has guided everything since the beginning. Move straight through space-time. Let space-time decide what straight means. This idea raises a question that sits at the edge of reason. If space can bend a little, can it bend more? If it bends enough to curve the path of light, can it bend enough to create a closed path? Could space be shaped so sharply that a photon circles forever, chasing a path that always returns to itself? Could space-time trap light not by force, but by shape? The answer to that question lies deeper inside the universe than most people will ever imagine. The most extreme example of gravitational bending leads to the threshold of a black hole. But before we reach that realm, we must understand how light behaves when the bending becomes stronger and the geometry becomes tighter. We must follow light into the places where space itself warps like a funnel. The photon continues to travel free of mass, but the path becomes more and more distorted. In mild bending, we see arcs. In stronger bending, we see circles. Space can redirect light like a whisper redirecting smoke. It does not touch the photon. It touches the universe, and the photon simply obeys. This is the universe telling us that straight and curved are illusions. Only space-time decides the path. When we look at images from powerful observatories, we see arcs of light stretched across darkness. These arcs are real photons, traveling for hundreds of millions of years, distorted because the space they crossed was uneven. We expect space to be flat. We imagine the universe as a giant room, cool and silent. But light shows us the truth. The room has shape. Space buckles. Space twists. Space can deepen like a valley or narrow like a canyon. Light simply follows the terrain. When bending is subtle, we see delicate arcs. When bending is stronger, we see the same galaxy copied into several positions. These copies are not reflections. They are different paths of the same photons arriving at different angles. If the mass is perfectly arranged and our line of sight is precise, the bending produces a full ring of light. Scientists call this an Einstein ring. It forms when light from a distant galaxy passes around a massive object and reaches us from all directions. What appears to be a perfect circle is not a structure in space. It begins as one image. The lensing splits its path into many segments of geometry that loop around the massive object. Light reveals that the space surrounding that object has become circular in its curvature. Light behaves as though the universe is filled with invisible lenses. Every star, every galaxy, every cluster changes the map beneath light. None of these objects pull on photons. They reshape the arena photons travel through. The universe is not a silent room. It is a landscape of valleys and peaks. Light is the water that flows across it. Consider again a photon leaving a distant galaxy. It is born when an electron jumps from one energy level to another inside an atom. The photon leaves with a specific energy, a specific wavelength, and only one purpose: move. It travels outward in perfect straightness. If nothing bends space, the path remains straight. But if the photon approaches a region of space-time sculpted by mass, that region is not flat. It is curved. Light will take the shortest distance in this curved space. That shortest distance is what we observe as a bend. To the photon, nothing special happened. It did not sense the curvature. It did not resist or struggle. It simply traveled the only path the universe offered. This fact becomes astonishing when we apply it to objects of extreme mass. Galaxy clusters, the largest gravitational formations in the universe, can bend so much light that they reveal galaxies far behind them. The photons from those hidden galaxies take routes shaped by the mass of the cluster. When those photons reach Earth, the image is distorted into stretched arcs. Able 370 shows this effect beautifully. A single cluster bends the entire background into ethereal streaks. Light that should have passed by unobserved becomes magnified and exposed to us. The universe behaves like an artist. Space-time sketches strokes of light across the canvas of darkness. We see beauty born from geometry. Gravitational lensing proves something extraordinary. We can use curvature to measure mass that we cannot see. If there is more bending than expected, something invisible must be shaping space. That something is dark matter. We do not know what dark matter is made of, yet we know where it is, because light obeys it. Photons have no rest mass, but they reveal mass by following geometry. Light does not interact with dark matter directly, but it obeys the shape that dark matter creates. This means light is the messenger of invisible structure. Without light, we would never know the universe contains far more mass than we can see. Without gravitational lensing, we would not know that galaxies are surrounded by unseen halos of matter. Without bending, we would not know that most of the mass in the universe is hidden. We think of light as simple brightness, but it is more than that. Light is measurement. Light is proof. Light is the witness of reality. The more we observe this bending, the bolder the questions become. If a cluster of galaxies can bend light gently, could something bend it completely? Could space curve enough that light no longer escapes? Could light be held in place, not by force, but by geometry? Imagine pouring water around the inside of a smooth bowl. The water flows downward. It settles in the center. Now imagine that bowl is the curvature of space. If the bowl is shallow, water can escape. If it becomes deeper, escape requires more speed. If the bowl grows deep enough, the water can no longer reach the edge. Light behaves the same. When space curves modestly, the photon continues on a slightly altered direction. When curvature deepens, the path becomes more distorted. If curvature grows extreme enough, every possible straight line leads inward. At that point, not even light can escape. But before reaching that final well of gravity, an intermediate state exists where something extraordinary happens. Light can orbit. A photon can circle a massive object the same way a planet circles a star, yet this orbit is far more precarious. Unlike planets, photons cannot slow down or speed up. They always travel at the speed of light in vacuum. If they move a little too far from the massive object, they escape forever. If they move a little too close, they spiral inward and vanish. There exists only one exact path where light can orbit indefinitely. This region lies at 1.5 times the radius of the event horizon of a black hole. Scientists call that distance the photon sphere. At that location, space-time has curved so precisely that the quality of straightness leads in a circle. A photon entering that region becomes trapped in an endless chase. It follows a perfect loop because every direction forward bends back onto itself. The photon sphere is the ultimate demonstration that curvature guides motion. Light, the most free traveler in existence, becomes a captive of geometry. Yet even then, nothing touches it. Light is not pulled. Light is not forced. The shape of reality simply gives it no other option. Light is the most honest traveler in existence. It never argues. It never negotiates. It moves exactly where space-time allows, even when that path twists into impossible shapes. The photon does not fear the curve. It simply follows it. Yet as the curvature deepens, something remarkable begins to happen. The bending becomes so strong that light no longer appears merely shifted or stretched. It becomes sculpted. Picture a photon approaching an intensely curved region of space-time. From a distance, the path looks straight. Closer to the massive object, the straightest line begins to tilt. Draw closer still, and the line bends more sharply. At a specific distance from a black hole, exactly 1.5 times the radius of the event horizon, the geometry becomes perfect for an endless chase. The photon enters the photon sphere. Here, the meaning of straight has changed so dramatically that moving forward returns the photon to the same point. The path through space-time becomes a perfect loop. There are no walls, no barriers, no contact, only geometry. If the photon approaches slightly above that path, it escapes and continues on its journey. If it approaches slightly below that path, it spirals inward and disappears beyond the event horizon. Only along the exact radius of the photon sphere is the balance perfect. The photon circles forever, as though running on the rim of a cosmic whirlpool. When the Event Horizon Telescope captured the shadow of a black hole in the galaxy Messier 87, the bright ring surrounding the darkness was not the black hole itself. It was the glow of light orbiting near the photon sphere. Photons skimmed the edge of endless curvature. Some escaped outward and reached us. Others were trapped and continued their orbit until they inevitably crossed the event horizon. The bright ring is not an object. It is the trace of light obeying geometry. Light becomes a prisoner not because anything touches it, but because space-time no longer offers a direction that leads away. To visualize this, imagine that space around a massive object is a funnel carved into the fabric of existence. At the top of the funnel, paths are wide and gentle. A photon passing by barely changes course. Deeper down, curvature increases. Near the photon sphere, the funnel is so steep that the forward direction becomes circular. If the photon goes deeper, the funnel narrows into a throat that leads only inward. This throat marks the boundary we call the event horizon. Once a photon crosses it, no path leads outward. The meaning of forward becomes tied to falling inward. It is strange to imagine that direction is not absolute. We think forward is a simple concept, one step taken, 1 meter traveled. But direction only makes sense when space has a shape that allows multiple possible paths. Inside extreme curvature, paths collapse. Forward becomes inward. Time becomes movement toward the singularity. The universe shows no hesitation when redefining what is possible. Light circles in perfect silence. Every loop would take only a tiny fraction of a second. Yet to an observer watching from a safe distance, each loop reveals the curvature of space-time. The photon, however, does not know it is looping. It feels no time. It experiences no sense of motion. It only fulfills the rule that defines its existence. Move in the straightest possible line. Light obeys geometry with absolute loyalty. Once we understand this, the universe becomes clearer. The photon sphere is not mysticism. It is mathematics made visible. It is the physical proof that curvature guides motion, and motion exposes curvature. Every orbiting photon is a message that space has bent so tightly that straightness becomes circular. This is the ultimate form of lensing, not gentle bending, not magnification, but entrapment. Light, the most free traveler known, can be held captive by geometry alone. This realization reshapes how we think about freedom. We imagine freedom as movement without interference, but freedom is also defined by the shape of the world we move through. The photon is free, but the universe decides the map. To escape, the photon would need a direction that leads outward. In the photon sphere, That direction no longer exists. The idea that geometry can trap light leads us to a deeper truth. If light cannot escape a region of curved space-time, then nothing else can. No object with mass could ever outrun a photon. If the photon has no path that leads outward, neither does anything else. The photon sphere marks the gateway to the extreme. Beyond it lies the event horizon and the singularity. But before we enter that realm, we must understand something subtle. Space does not grab the photon. It shapes the arena so that every step forward draws the traveler closer to the center of gravity. We now return to a question first asked quietly many chapters ago. Can gravity trap something without touching it? The answer stands before us in the photon sphere. The photon is massless. It feels no force. Yet here it is, circling endlessly, unable to escape. Not because a hand holds it, not because a rope tightens around it, because space curves. Space-time does not touch the photon. Space-time defines the path. Think again of the river carving a canyon. The water flows freely, yet the canyon shapes its movement. The water is not forced. It is guided. The photon is the water. Space-time is the canyon. Gravity is the shape of that canyon. The deeper the canyon, the fewer escape routes exist. At shallow depth, escape is possible. At extreme depth, escape is impossible. As we stand at the edge of this realization, we feel the boundary between what is familiar and what is unknowable. Light bends. Light orbits. Light may be trapped. But nothing yet has demanded that light disappear. That comes next. Beyond the photon sphere lies the point of no return. A horizon that is not a wall, not a surface, not a border made of matter. It is the place where geometry itself collapses every straight path into a single direction. Forward becomes inward. In the next chapter, we will cross that boundary and witness the moment light no longer orbits, no longer bends, and no longer escapes. We will stand on the edge of the event horizon and realize that trapping light requires no touch at all. Space-time alone is enough. There comes a moment when space itself gives up all possibilities of escape, not because a force grows stronger, but because the very meaning of direction collapses. At first glance, nothing about a black hole looks unusual. In empty space, there is no surface, no solid boundary, no wall. If you approached a black hole while drifting in the darkness, you would see no sign marking the threshold between freedom and captivity. There would be no change in texture or color. Space looks the same as it always has. Yet at one particular distance from the center, space-time undergoes a transformation so absolute that it cannot be reversed. This invisible boundary is called the event horizon. It is the place where all possible paths forward lead inward. To understand how this boundary forms, imagine once more that space behaves like a landscape. A massive object creates a depression, a valley in the fabric. A planet makes a small valley. A star creates a deeper valley. But a black hole creates something beyond a valley. It creates a pit that steepens without limit. At modest curvature, you can climb back out. At greater curvature, escape requires tremendous speed. At a very specific depth, escape becomes mathematically impossible. The depth of this boundary is defined by the escape speed required to move outward. At the event horizon, that speed equals the speed of light. Light is already traveling at the greatest speed that nature allows. It cannot go any faster. If escape requires more than the speed of light, escape cannot occur. Nothing touches the photon. The photon simply finds that every path leads deeper. Imagine you are drifting toward a black hole. At a great distance, you see the stars around you, just as you always have. The region appears calm. If your spacecraft has engines, you could fire them and change direction. You could leave whenever you wish. As you drift closer, space slowly begins to curve. Paths forward are not quite the same as paths outward. The change is subtle. You do not feel it. At this stage, Light passing near the black hole bends, but escape is still possible. You are still outside the event horizon. Move closer. The curvature deepens. Space is no longer flat under your motion. You could still turn around, but you would need more speed. If you shine a beam of light sideways, you will see it bend slightly inward. It continues straight through space-time, but space-time itself is not straight. A photon entering this region experiences no contact, no push. It follows geometry. Then you cross the boundary. There is no alarm, no flash of warning, no resistance. You simply pass a point where the straightest possible path leads inward. Once inside, every direction you can travel, even the direction you think of as outward, still moves you closer to the center. The event horizon is not a surface. It is a threshold in the structure of space-time. Outside it, escape is difficult but possible. Inside it, escape is no longer part of reality. Even if you turn on engines strong enough to accelerate a planet, even if you aim directly away from the center, every bit of motion still leads inward. Forward has changed meaning. We talk about falling as though some force presses us downward, but falling into a black hole is different. You are not pulled. You are allowed to follow the purest possible line through space-time. Inside the event horizon, that line plunges toward the center. From far outside the black hole, an observer watching you fall would see something strange. You would appear to slow down as you approach the horizon. Your signals, the very photons carrying information about you, would take longer to escape the deep curvature of space-time. They would stretch into longer and longer wavelengths, becoming redder and dimmer. Eventually, the light escaping from you would shift so far into the red that it would no longer be visible. To that distant observer, time seems to stop for you right at the horizon. You appear frozen at the edge, never crossing, fading into darkness. But from your perspective, nothing special happens. Time continues normally. You cross the horizon in silence. No flash, no sudden change. You simply drift into a region where outward no longer exists. In your own experience, you cross the boundary in a finite moment. Two experiences, both true. One observer sees you freeze and fade. The other experiences motion without interruption. This is not paradox. It is space-time behaving according to rules that we can now understand. Time is part of the fabric. When the fabric curves strongly, time stretches. At the event horizon, the stretching becomes extreme. Inside the horizon, light can only move inward. Since nothing can outrun light, nothing else can escape. In this realm, light is not caught by force. Light is caught because geometry has removed all other paths. The moment light passes that boundary, its future lies at the center. There are no alternate futures. For light, existence means motion. Crossing the horizon does not stop its motion. It simply confines that motion to a single path. In the deepest sense, the event horizon is not a prison built from walls. It is a region where the universe has run out of alternatives. From the outside universe, information does not return. The event horizon becomes the ultimate one-way boundary, not because it resists matter or blocks light, because all possible futures have become one future. Inside, the rules are different. Space and time trade roles. Moving forward in time means moving closer to the center. The future is not a direction among many. It becomes a direction toward a singular point, the singularity. The event horizon is the edge of this transformation. Once inside the event horizon, motion and time become inseparable. You do not choose to fall. Falling becomes the definition of your future. Every second draws you closer to the center. Even if you try to steer, even if you fire rockets that could push mountains, every effort still results in movement toward the singularity. You are not being forced. You are not being held. You are simply following the only path the universe now permits. The geometry has removed all alternatives. Think of time the way you think of breathing. You may hold your breath for a moment, but eventually, breathing resumes. The body demands it. Inside the event horizon, moving toward the center is not a choice. It is the unfolding of time. To move any other direction would require breaking the structure of space-time itself. Before crossing the event horizon, space surrounds you. Time stretches smoothly forward. You have a past behind you and a future ahead. But once inside, the fabric shifts. The inward direction becomes the new future. The center is no longer a location you approach. It becomes the place where your timeline ends. You do not feel this shift. You simply live through it. The universe has rewritten what forward means. Outside the event horizon, the escape speed may require enormous power, but escape is still allowed in principle. Inside, escape is no longer part of the fabric. A photon moving at the speed of light cannot outrun the direction that space-time calls forward. If light cannot escape, nothing can. A photon travels because it must. It continues because existence demands motion. But motion is no longer free. Inside, motion is fate. As you descend inward, something unsettling begins to happen. The tidal forces that were once gentle grow stronger. Imagine that gravity is not a constant pull, but a difference in the curvature of space-time between your head and your feet. Near Earth, that difference is tiny. Near the horizon of a massive black hole, it remains small enough that you feel almost nothing. But deeper in, the curvature grows rapidly. If the black hole is relatively small, the difference in curvature from head to feet becomes dramatic. Your body begins to feel stretched, as though space itself is trying to unweave you. Scientists call this tidal stretching. Some have given it a nickname that sounds playful, but describes a real and unavoidable effect. The deeper you fall, the more that stretching increases. But in the case of extremely large black holes, the event horizon may be so vast that this stretching does not become noticeable until long after you have crossed the boundary. You could drift through the horizon without any sensation of harm. You would not know you had crossed the point of no return. You would continue onward, unaware that the future has narrowed into a single destination. To a distant observer, it appears as though time slows for you as you approach the horizon. The light you emit or reflect becomes stretched into longer and longer wavelengths. It fades toward red, then toward infrared, then toward wavelengths too long to detect. Eventually, even the faintest trace of light released from you is shifted into wavelengths that drift unseen into the background of space. To that observer, you never cross. You fade into silence. Yet from your own point of view, nothing changes. You cross the horizon and continue. Time flows normally. Your heartbeat stays steady. You do not freeze. You do not fade. You fall. The contradiction is not a trick. It is what happens when space-time stretches time itself. The observer far away and the traveler falling inward are both correct. This dual truth is one of the strangest gifts given to us by relativity. Past the horizon, the space around you behaves differently. The universe outside can no longer send signals inward. Even a photon generated just beyond that boundary cannot cross into the horizon from the outside. The horizon is not a wall that you collide with. It is a separation in the flow of information. Anything outside cannot reach you. Anything inside cannot return. Space has become divided, not by material barriers, but by geometry. The final approach toward the center brings you into a region where the concept of direction completely breaks down. The inward path is no longer a journey. It is a collapse of time. Space shrinks faster than your motion. Every second, the distance to the center becomes smaller by a factor that grows exponentially. You feel the narrowing. You see the distortion. Ahead lies the singularity, a point where all the space-time curvature becomes infinite. That word infinite is not an exaggeration. It means the equations we use to describe the universe no longer produce numbers. They break. They collapse into mathematical silence. The singularity is not a place in space. It is the end of space, in every direction. At that point, we no longer have language capable of expressing what happens. Physics, as we understand it, stops providing answers. The geometry collapses. Time ends. Before reaching that collapse, however, one final truth becomes clear. The event horizon did not arise because light was pulled inward by some invisible force. Light was trapped because the shape of space-time no longer included any possible outward path. Gravity never touched the photon. The universe simply removed freedom of movement. This realization is perhaps the most important of all. A black hole does not trap light by force. It traps light by redefining what directions exist. Everything that reaches the horizon is governed by new rules. Everything that crosses the horizon loses access to other futures. The event horizon is not the edge of a thing. It is the boundary of possibility. The event horizon feels like an ending, but in truth, it is a transformation. The world before you behaves according to familiar rules. The world ahead obeys a different structure. Until this moment, the universe has offered choices. You could travel here or there. You could move outward or inward. You could follow the curvature of space-time or resist it with engines and force. At the horizon, those choices disappear. Space-time has shaped a destiny. Every path now leads toward the singularity. Outside the horizon, time and space behave as partners, flowing smoothly and predictably. Inside, the roles of time and space trade places. What was once a direction you could choose becomes the direction of your future. You cannot stop yourself from reaching the center, not because you are being pulled, but because the inward direction has become time itself. The singularity is not a location to travel to. It is a moment you must reach. The future is an unavoidable collapse into one point. Imagine floating within a silent chamber. No sound, no light other than what travels with you. The stars outside the horizon fade into an unreachable past. You carry motion, but motion no longer means what it once did. Even light cannot outrun fate here. Light tries to move outward, but outward has vanished. The photon continues forward, as it always has. But the path ahead leads only to the singularity. Nothing physical pushes it. Geometry dictates its destiny. From the outside, the universe watches without being able to intervene. Photons sent outward from your ship stretch into longer and longer wavelengths as space around you accelerates their departure. At first, they appear redder. Then they fade into wavelengths too long for human eyes. Finally, they slip into wavelengths that instruments cannot detect. To the outside universe, you have already become lost. Your final signals drift into silence long before you reach the interior. Inside, time behaves normally for you. You do not slow down. Your heartbeat does not hesitate. Your mind continues to think. Yet every heartbeat brings you closer to the singularity. The distance shrinks faster than your motion because distance itself collapses. The shrinking of space is not a sensation. It is the reality of how geometry controls the shape of every possible path. Your world narrows. The black hole dominates every direction. If you look sideways, light moves inward. If you look backward, the space behind you folds toward the center. If you look ahead, you see nothing at all. No sky, no stars. Only a direction that is simply your future. You have not lost the universe. The universe has lost you. The concept of free movement ends here. Free will cannot. Choose a path that geometry does not allow. Your choice remains only in how you experience the journey. The end will arrive because time insists on it. The singularity is not a region you reach by traveling. It is the moment at which your timeline ends. Everything you are, everything you know, falls into that point. In these last moments before the collapse becomes absolute, the structure of space-time reveals something profound. Space does not simply dictate motion. Space defines the set of possible futures. Outside the event horizon, possibility unfolds like branches extending outward. Inside, all branches fold into one. Time does not lift you, it funnels you. The universe offers fewer and fewer futures until there is only one. The singularity waits. It is not a point made of matter. It is the end of geometry. At the singularity, curvature becomes infinite. Space-time breaks the way a compass breaks at the North Pole. Lines that once defined direction converge into one indistinguishable place. Every law that guides the cosmos ceases to speak. Mass and energy collapse into something we cannot describe. The equations that have guided us fail. As you fall inward, you notice the world around you distorting. The deeper you go, the stronger the tidal effects become. They stretch you because space-time itself stretches. If the black hole is small, this stretching reaches you before you approach the singularity. Your body becomes elongated as different parts of you follow geodesics that diverge. If the black hole is enormous, large enough that the event horizon is far from its center, this stretching may not be noticeable until the very last moment. For a time, you may drift unharmed. Eventually, the curvature becomes too intense to ignore. Your body is not torn apart by force. Your atoms follow different paths through space-time. They reach different futures because the geometry beneath them differs. Matter does not unravel because something grips it. It unravels because space-time tells every part of it to move toward a different part of the singularity. Yet perhaps the deepest revelation is this: gravity never touched you. Even now, at the very end, no force presses you inward. No invisible hand pulls you. The universe simply stops offering any direction except toward the singularity. You are not being acted upon. Your motion is simply the unfolding of time. Everything outside continues. Stars orbit. Galaxies collide. Light travels through the vastness. Children are born. Worlds spin. None of those events reach you anymore. Their photons, even traveling at the speed of light, cannot cross the event horizon to tell you what happens after you fall. The universe continues without you. Space-time has reached a point where it cannot hold together the rules that once governed it. At the singularity that lies ahead, the curvature becomes infinite. The equations of general relativity that once described motion with certainty become meaningless. They produce no answer. They cannot describe what lies beyond. We stand here at the limit of known physics. The traveler reaches the singularity. The journey ends. Space and time meet their edge. Beyond this point, our understanding fails, but we have learned what we needed to see. Light did not bend because it was pulled. Light followed geometry. Motion did not collapse because of force. Motion followed the shape of space-time. The event horizon did not capture light by touch. It captured light by eliminating the possibility of any path that leads away. Gravity did not trap light. Curved space-time trapped light. The path is the prison. There exists a narrow borderland outside the event horizon, where light experiences something almost impossible. It enters a region where the bending of space-time is neither gentle nor absolute. Space curves so precisely, so sharply, that light no longer travels past the black hole and no longer falls into it. Instead, the photon becomes trapped in a perfect circular path. It travels at the speed of light, obeying the only law it has ever known. Move forward, move straight, follow the geometry. But here straight has become a circle. This fragile location, balanced between freedom and oblivion, is called the photon sphere. Unlike the event horizon, it is not the point of no return. It lies farther out, at exactly 1 1/2 times the radius of the event horizon. That distance is not arbitrary. It is the unique point where the curvature of space-time requires a photon to loop around the black hole rather than escape outward. The photon is not held by force. It does not collide with a barrier. It does not feel any pull. It simply discovers that every straight path leads along a circle. From the outside universe, this seems like a miracle. The idea of a particle with no mass orbiting a massive object feels contradictory. How can something that is always moving at the same speed curve at all? Yet the photon does not curve. the space through which it moves curves. The photon continues in the straightest possible line, but the surface that defines straightness wraps around the black hole like a whirlpool. Imagine a marble moving on a curved bowl. The marble is not forced to move in a circle. Instead, the bowl reshapes what straight means. The marble follows the shape of the bowl. It never stops being free. The photon behaves the same way. The freedom remains absolute, but the map beneath that freedom has changed. Straightness has become circular. The photon does not resist. It simply continues. The photon sphere is not a place of stability. It is not an orbit like the orbit of a planet around a star. A planet can be nudged, and the orbit remains. A slight change does not doom the motion. But inside the photon sphere, even the smallest deviation is catastrophic. A photon that drifts slightly outward escapes forever. A photon that drifts slightly inward crosses the event horizon and falls toward the singularity. Only one perfect trajectory keeps the photon circling the black hole. It is a razor-thin balance, an orbit defined not by gravity pulling, but by space-time curving. Light does not experience time. It does not feel motion. For the photon, the journey from origin to destination is instantaneous. Yet in this region of perfect curvature, the photon chases itself endlessly. If it possessed awareness, it might believe it is moving straight ahead. In truth, it is trapped in eternal motion, not by friction or force, but by the geometry of the universe. The Event Horizon Telescope revealed this region to us, not as theory, but as an image. When scientists captured the shadow of a supermassive black hole in the galaxy Messier 87, the bright ring we saw was not the event horizon. It was not the black hole. It was the photon sphere. Light skimming the edge of space-time was orbiting and escaping, creating a ring of brightness around darkness. The black circle in the center is the region where no photon ever returns. The ring around it is the glowing evidence that photons are circling on the edge of eternity before some of them escape to reveal what lies there. The sight of that ring changed humanity. For the first time, we saw geometry itself shining. Not a surface, not matter, not a star. Geometry. It is easy to forget that light carries information. Every photon that reaches our eyes or our instruments shows us places we have never been. Every photon teaches us the shape of space-time by following its curves. When a photon orbits the black hole, it traces that shape again and again. The photon sphere is therefore not only a region of trapped light, it is a region where geometry becomes visible. The idea that light can orbit something defies our instincts. Light forever moves in straight lines. Our intuition tells us that if you shine a flashlight across an open field, the beam will travel outward forever until absorbed by something. We imagine straight paths through empty space. Yet near a black hole, empty space is not empty. Space bends under the weight of mass. The flashlight beam follows that bending. To reach the photon sphere requires an unimaginable journey. The curvature near a black hole intensifies rapidly. The laws we take for granted begin to behave differently. Directions lose their meaning. Distances become treacherous. The photon sphere is the last place where light can remain free. It is not yet forced inward, but escape is unstable. The moment a photon deviates from the perfect circle, the universe decides its fate. Some photons escape outward and continue their journey across the cosmos. Others spiral inward and never return. The photon sphere is a cosmic coin flip. The photon cannot choose. It only follows the path that space-time offers. It is here, in this circular trap of geometry, that we see a fundamental truth. Light is not guided by force. Light is guided by the structure of space-time. It always has been. The photon sphere reveals that curvature can create confinement, not by grabbing the photon, by removing every other path. The closer a photon comes to the black hole, the fewer possible futures remain. At the photon sphere, two futures exist: escape outward or fall inward. Slight differences decide immense consequences. A photon may travel billions of years only to be lost in an instant. We tend to think of black holes as destroyers, objects that swallow all matter and light. But that picture is incomplete. Black holes are not predators. They are sculptors of space-time. They reshape the fabric of the universe so intensely that even the concept of forward becomes altered. Light, loyal to geometry, responds without hesitation. The photon sphere shows us the knife edge between freedom and doom. Some photons escape and show us the edge of darkness. Others fall and vanish from our universe forever. And yet, within that razor-thin boundary, light dances in circles. A dance of laws older than stars. A dance choreographed by the shape of space itself. At the photon sphere, light becomes a prisoner of almost perfect balance. It is a region that defies everything we believe about motion. Light is the fastest traveler in the universe. Nothing outruns it. Nothing catches it. Yet here, light can orbit like a planet. A photon enters this narrow ring and becomes locked in motion around the black hole. It tries to continue straight, as it always does. But straightness in this region means looping endlessly around a curve that space itself dictates. The photon does not know that its journey no longer leads outward. It does not feel loss of freedom. It only follows the path space-time commands. The reality of this place is delicate. A photon aligned perfectly with the curvature of the photon sphere orbits endlessly. But this condition is razor-sharp, a fraction of a degree outward, and the photon escapes. A fraction inward, and it spirals toward the event horizon. It is the most precise threshold in nature. In the entirety of the universe, there is no more unstable place for light to exist than on the surface of this invisible ring. The orbits have no flexibility, no forgiveness. They are perfect or they end. Imagine a narrow ledge carved into the side of a mountain. If you stand exactly centered, you remain in balance. If you move a hair outward, you fall to the open world below. If you step inward, you tumble into darkness. The photon sphere is that ledge made from geometry itself. Light walks that ledge at the speed of light. Every instant balanced between fate and freedom. The photon sphere is not unique to enormous black holes. Every black hole, no matter how large or small, forms this boundary. The radius may scale with the mass of the black hole, but the same law applies. Light has only one orbit that can remain stable, and even that stability exists only in theory. The slightest disturbance, even a slight irregularity in the surrounding space, sends the photon drifting to one of its two destinies: freedom or oblivion. And yet, this fragile phenomenon reveals answers to some of the deepest questions we can ask. When the Event Horizon Telescope captured the image of the supermassive black hole in Messier 87, the brilliant ring we saw was not solid matter. It was not glowing gas. It was light skimming the region of the photon sphere. Some photons, completing several full orbits before escaping, eventually reached Earth. When they reached the telescopes forming the array, they carried the map of space-time itself. The ring we see is not a physical ring. It is a last glimpse of freedom before geometry becomes absolute. That glowing circle is the universe showing us the path that light travels when the very definition of straightness becomes circular. When you stare at that image, you are witnessing the warping of space-time made visible by the most obedient traveler in existence. Light does not fight the curve. It traces it. It paints the shape of space-time with every orbit. Without light, we would never know the photon sphere exists. Without photons escaping that region, we would never see the silhouette of a black hole. Light gives shape to the invisible. Many people imagine a black hole as a devouring monster, an insatiable suction point that pulls everything inward. But the true nature of a black hole is geometry. It has no appetite. It has no intention. It does not reach out. Space simply bends so dramatically that all possible futures lead inward. The photon sphere is the last place where the photon still possesses more than one possible future. Even here, the window of escape is nearly non-existent. Yet, from a distance, we see only beauty. We see light caught in a loop, painting circles around darkness. The image of Messier 87 inspired awe across the world because it was a silent revelation. The universe is not built from objects. It is built from structure. It is built from rules. Light follows those rules perfectly. Think of what this implies. A photon that has traveled across the universe may arrive at a black hole and, if its path aligns exactly, become trapped in orbit. It may circle countless times before eventual escape. Some orbits last long enough that the photon travels enormous distances, while never leaving the same small region. Light may spend long ages looping around a black hole only to be released later and continue its journey as if nothing happened. To human observers, the photon arrives carrying no hint of delay. It has no internal clock. It simply arrives. It does not experience the orbit. It only fulfills the path. You could say that a photon does not know it was trapped, but photons reveal the shape of space-time regardless of their awareness. When a photon escapes the photon sphere after several orbits, it carries information from multiple angles around the black hole. When these multiple escape routes reach us, we can reconstruct the geometry of the object, even though light never touched it. We learn the mass of a black hole through the geometry it imposes on light. The photon sphere therefore acts as a natural probe, a perfect instrument, a cosmic scanner, and all of this unfolds without a force. The photon sphere stands as proof that the universe does not need to pull on light. It only needs to shape the space around it. Light obeys the shape. As we continue to study black holes, we now believe that some of the brightest flares seen near the edge of a black hole may be enhanced by light, completing multiple loops around the photon sphere. Light amplified not by material interaction, but by multiple, passes through a curved path. These flares are signatures that tell us photons are circling, waiting for a moment when geometry allows escape. Even more extraordinary, some simulations suggest that if you were able to hover near the photon sphere, you might see repeated images of the universe behind you. Light from distant stars could reach you after looping multiple times around the black hole. You would see the universe wrapped around itself. A ghost gallery of images, warped and repeated. Not illusions, real photons, real geometry, real light tracing the shape of a gravitational well so severe that straightness folds back on itself. You would not be seeing a distorted reflection. You would be seeing space-time. The photon sphere shows us something profound about reality. Space is not passive. Space shapes movement. Space shapes possibility. Light, the traveler that refuses to slow or stop, reveals that shape. Beyond the photon sphere lies the event horizon. Beyond the event horizon lies the singularity. But the photon sphere is different. It is the last ledge of freedom. It is where light hesitates between escape and destiny. The idea that something moving at the speed of light can hover in place seems impossible until we understand the rule. The photon is not hovering. It is moving straight. Straightness has been redefined by the universe. There is a strange beauty in how the photon sphere teaches us about reality. When we talk about orbits, we imagine familiar things: planets circling stars, moons circling planets, satellites circling Earth. Those orbits depend on velocity and distance. Adjust either one and the orbit changes. A planet can exist in an enormous range of distances and still remain bound. A satellite can follow a path that is stable and forgiving. The system allows error, but the photon sphere does not allow error. It is an orbit balanced on the edge of a cosmic blade. To exist on that razor circle, a photon must arrive at exactly the correct angle, moving through space-time at exactly the correct radius. Not nearly correct, exactly correct. There is no wiggle room. Escape requires only the tiniest change. Doom requires only the tiniest change. The photon sphere is not a place of safety. It is a place of tension, a region so thin that stability becomes an illusion. Imagine watching a dancer balance on the very tip of a needle. One wrong movement sends the dancer falling. Now imagine that dancer moving at the speed of light. No friction, no rest. Eternal motion, guided only by the shape beneath their feet. That is the photon sphere. The photon does not orbit because something grabs it. The photon orbits because space-time has been sculpted into a closed loop. At the photon sphere, light becomes an artist tracing the geometry of reality. Every loop is a brushstroke. Every escape is a revelation. Every fall inward is a surrender. The consequences of these circular paths stretch far beyond the black hole itself. When photons orbit, the photon sphere, they can make multiple complete loops. On each pass, a small fraction may escape. By the time those photons reach us, they carry information about the region near the black hole from many different angles. That is why the ring in the image from the Event Horizon telescope is so bright. It is not single photons arriving. It is light that has been amplified through repeated loops. These photons are storytellers. They have seen the black hole from every side. Some physicists describe the photon sphere as the mirror of the universe. Light from every direction is allowed to loop and return. The result is a place where information becomes tangled around itself. If you could hover outside the photon sphere and look inward, you might see multiple copies of distant stars, each copy delayed by a loop around the black hole. The universe would appear doubled, tripled, multiplied. Every image would whisper the curvature of space. You would see the cosmos wrapped in a circle of itself. There is a temptation to think that the photon sphere exists to showcase beauty, but nature never creates things for us. We merely witness what the laws of the universe demand. The photon sphere exists because Einstein described gravity not as a force, but as geometry. Light does not bend because it is pulled. Light bends because space-time curves. If space-time curves enough, straightness becomes circular. This is the unavoidable conclusion of the rules we now understand. We tend to think that freedom is defined by speed. Light is the fastest traveler. Nothing surpasses it. If anything should be free, it should be light. And yet, freedom is not defined by speed. Freedom is defined by the number of possible paths. At the photon sphere, the number of paths collapses. Not completely, but nearly so. A photon can escape. A photon can fall. The photon sphere holds the final fragile choice. The deeper you go toward the black hole, the fewer paths exist. At the photon sphere, there are two paths. At the event horizon, there is only one. And beyond, there is no path, only the singularity. Motion becomes the collapse of time. In the photon sphere, light dances on the last circle where choice is still possible. What happens to matter that approaches this region? Matter does not orbit the same way light does. A particle with mass cannot travel at the speed of light. It cannot follow the exact path of the photon. If matter attempts to follow the edge of the photon sphere, it will always fall inward. Mass cannot maintain the perfect geometry required. The photon sphere is the exclusive realm of light. For matter, the universe allows stable orbits much farther away. For light, only this single distance works. The photon sphere is a threshold between two universes. Outside it, light can still carry information outward. Inside it, light lives its final instance of indecision before the event horizon decides its fate. Another truth emerges here. The photon sphere is the reason. Black holes have silhouettes. Without it, the boundary between light and darkness would be blurred. There would be no distinct edge. The photon sphere sharpens the darkness. It defines the outline by collecting and releasing light that grazes the event horizon without crossing it. The black hole is framed by light that refuses to fall until the last possible moment. If a black hole is a void, the photon sphere is its halo. The halo exists because the laws of nature insist that straightness follows the curve of space. The halo exists because freedom collapses. The halo exists because light does not resist geometry. Light honors geometry. Perhaps the strangest thought is what happens from the photon's perspective. If a photon could think, it might believe it is traveling straight and free. It does not sense the curve. It does not sense captivity. It only does what it has always done: move forward. From our perspective, we see the loop. From the photon's perspective, the loop does not exist. Time does not flow for light. The orbit is not a path. It is simply existence. For light, eternal orbit is a single unbroken moment. The photon sphere reveals that motion is not freedom. Geometry is. Beyond the photon sphere lies the event horizon. Beyond the event horizon lies the singularity. But here, in this narrow ring of possibility, the universe allows one final demonstration of its power. It shows us that even the most unstoppable traveler can be guided, not by force, but by shape. And in doing so, it reveals a truth that applies to everything. We do not move through space. Space moves us. Light leaves its birthplace without hesitation. A photon born in the core of a star escapes a furnace of unimaginable heat, passing through atoms and fields until it finally reaches open space. From that moment onward, light has one instinct: travel straight. No hesitation, no slowing, no weight. It carries no mass. It experiences no time. It moves at the fastest possible speed that nature allows. It does not consider where it is going. It simply goes. But near a black hole, that certainty collapses. Light approaches a region where space curves so severely that the meaning of direction changes as the photon moves. The closer it comes, the fewer futures remain. At first, the photon barely notices anything unusual. It travels onward, as always, unaware that every centimeter of distance brings it deeper into a geometry that will test the limits of freedom. Imagine the photon approaching from far away. The black hole is nothing more than a shadow in the tapestry of space. Around it, stars shine, gas glows, and light moves freely. But at great distances, the black hole imposes only the faintest curvature on space-time. The photon travels straight and continues on its path. If we could observe this from a distant place, we might not notice the black hole at all. As light draws closer, something subtle shifts. The straight path begins to curve. From the photon's perspective, nothing has changed. It is still moving straight. It is obeying the rule it has always followed. But space itself now curves like fabric being drawn inward. Imagine a marble rolling on soft fabric that has been pulled down toward a heavy object. The marble stays straight, yet its path bends because the surface beneath it bends. The photon is that marble. The universe is the fabric. The photon nears the photon sphere, that delicate ring where a perfect orbit is possible. If the photon arrives at the exact angle and at the exact radius, it will circle the black hole in a loop that is neither escape nor surrender. It will travel straight, but straight here means circular. A photon that arrives slightly too far outward will escape, fleeing back into the expanse of the universe. One that arrives slightly too far inward will be captured. Only one perfect trajectory achieves the orbit. Now imagine a photon that misses that precise path. The radius is slightly too small, the angle is slightly off. It crosses the photon sphere and enters the region where escape is still possible, but unlikely. The curvature deepens, the fabric steepens. Every direction begins to tilt inward. The photon continues forward. It has never slowed. It has never changed its speed, yet its future is different. It is passing from the land of possibility into the land of inevitability. As the photon reaches the edge of the event horizon, space-time has narrowed all futures to one. The photon does not feel resistance. It does not sense a wall. It only finds that continuing straight brings it inward. At the event horizon, the escape speed required to leave equals the speed of light. Nothing can go faster. Light reaches the limit, and the limit is not enough. Once past that boundary, all possible directions point toward the singularity. The photon's destiny is sealed not by force, but by geometry. Every path that remains leads inward. Time itself has changed direction. The photon still obeys the rule. Move straight. The meaning of straight has changed. A photon can orbit. A photon can escape. A photon can fall. But as long as motion is allowed, the photon moves without struggle. Energy flows. Position changes. Geometry decides. This is where the tug of war begins. Gravity does not pull the photon. Gravity shapes space-time. The photon does not resist gravity. It follows space-time. The dance between them is not force against force. It is law against law. Light holds the rule of constant speed. Gravity holds the rule of curvature. When they meet, they do not struggle. They negotiate. The black hole bends space-time inward. The photon tries to continue straight. The result is a curved path. The closer the photon gets, the more intense the bending. Space curves so sharply that light begins to spiral like a leaf caught in a whirlpool. Each loop tightens. Each moment brings the photon closer to a future with fewer options. It is not dragged, it is guided. The struggle is not physical, it is geometric. From the outside universe, an observer watching the photon sees something astonishing. Light that escapes the black hole's gravity well loses some of its energy. That energy does not disappear. It changes form. As light climbs away from the curved region of space-time, its wavelength stretches. It becomes redder. The process is called gravitational redshift. You can think of it like spending energy to climb a steep hill. A photon that leaves a deep gravity well must give up energy to escape. But light cannot slow down, so it gives up energy by changing its wavelength. It becomes redder because less energy means longer wavelength. A photon that barely escapes a black hole does not escape unchanged. It climbs upward, losing energy as it goes. Its wavelength stretches until it slips from visible light to infrared, then to microwave, then eventually into wavelength so long that the photon carries almost no usable energy at all. It does not vanish. It simply becomes something the universe can no longer detect. A photon falling inward experiences the opposite. As it moves deeper into the gravity well, space-time steepens. Light gains energy. Its wavelength shortens. It becomes bluer and more energetic. Near the event horizon, light that falls inward is stretched so dramatically that it shifts beyond ordinary blue into more energetic forms. The photon that enters the gravity well does not notice any change. Light has no way of sensing the stretching of its wavelength. The photon has no internal clock. The change is visible only to an observer far away who sees the photon arriving with a different color than expected. This color shift, this red shift and blue shift, is the signature of the tug of war. Gravity shapes space-time. Light reveals the curvature by changing its energy. Now imagine not one photon but a stream of photons. A beam of starlight approaches a black hole. Some photons miss the photon sphere and escape. Others graze the photon sphere and orbit before escaping. A few cross the event horizon. The deeper ones fall inward. As each photon travels, it loses or gains energy. Each photon tells a different story about the space-time it passed through. The universe is a storyteller, but light speaks the tales. When a photon finally crosses the event horizon, its future becomes singular. All possible paths have collapsed into one. It continues into the black hole, not because gravity pulls it, but because space no longer offers any alternative path. The photon obeys geometry. It has no choice. At the final moments before it crosses the event horizon, the photon undergoes the most dramatic stretch of all. From the outside universe, the light fades. Its wavelength grows longer and longer, disappearing from visible light into softer infrared, then into microwave, until it becomes so stretched that it blends into the background noise of the universe. Light does not fade because it weakens. It fades because space-time stretches its message. Inside the black hole, time collapses. The photon's path ends at the singularity, not because it stops moving, but because moving forward is the only future that exists. The geometry defines destiny. The singularity is not a place in space, it is a moment in time, and the photon reaches it. There is a quiet sadness in that, if sadness could apply to a particle that does not experience emotion. Light spends its existence revealing the cosmos, crossing the universe for billions of years, only for a single misalignment to bring it to a place from which information never returns. The photon disappears not from existence, but from the set of futures that connect to the rest of the universe. Inside, the photon has no witness, and so ends the tug of war. Light never stopped moving straight. Gravity never touched the photon. The only change was the shape of the playing field. The lesson is simple. Light does not curve. Space curves. Light follows. We live in a universe that seems ruled by forces. Push a cup and it moves. Throw a stone and it arcs through the air. Strike a nail and the hammer forces it downward. Everything we know from everyday life tells us that motion changes only when something pushes or pulls. That is the way we experience reality on Earth. But the universe is not built from our daily experiences. The universe is built on rules that stretch beyond instinct. Gravity appears to be one of those forces. A falling object seems to drop because Earth pulls it. We feel held to the ground because something presses on us. We assume that gravity touches matter and pulls it downward. But this idea is a misunderstanding born from simplicity. Gravity is not a force reaching out and grabbing. Gravity does not touch anything at all. Gravity reshapes the stage on which everything moves. Space and time are the arena. Gravity is the bending of that arena. To understand how strange and profound that truth is, imagine a traveler walking across a landscape without knowing its shape. If the ground slopes downward, the traveler will walk downhill. If the ground slopes upward, the traveler must climb. If the land curves into a valley, the traveler naturally descends into that valley. The shape of the land guides the journey. The traveler does not need to be pushed. The path emerges from geometry itself. This is what space does to light. Light always travels the straightest possible path. It does not bend because something forces it to bend. It bends only when the space through which it moves is curved. You could say that light does not obey gravity. It obeys space-time. The black hole does not reach out to touch it. The black hole sculpts the path beneath it. When Einstein realized this, he changed the way humanity understands the cosmos. He proposed that mass and energy tell space-time how to curve. Then space-time tells everything how to move. Matter does not need to feel a force. It simply follows the path carved into space. Light does not need to be touched. It follows the blueprint that the universe presents. Gravity acts on space. Light acts on the shape of space. Imagine space as a vast sheet stretched tight, smooth and flat. A photon moves across it in a straight line. Now imagine placing a heavy sphere in the center of that sheet. The sheet curves downward. A marble rolling near the sphere will move toward it, not because the sphere pulls the marble, but because the marble follows the curved surface. Replace the marble with a photon. Replace the sheet with space-time. This is not an analogy, it is the truth of the universe. Light does not need to feel gravity. Light only needs to follow space-time. We often speak of gravity as a field, but fields imply an invisible influence acting on objects. Gravity is not a field acting on matter the way magnetism acts on iron. Gravitation is geometry. We do not fall because Earth pulls us. We fall because the space near Earth is curved inward. When you drop a stone, you are not forcing the stone downward. You are releasing it from whatever held it away from the path space-time demands. The stone's fall is freedom. If you stand on Earth, you do not fall because the ground stops you. It pushes you upward, resisting the natural path that space-time has prepared. You are not held to Earth by a pull. You are kept above Earth by a push. This seems backwards because instinct tells us that falling requires a force. But falling is the absence of force. Falling is motion without resistance. Light falls too, not because gravity touches it, but because the path of least resistance curves inward. The deeper the mass, the sharper the curvature. A planet curves space modestly. A star curves space significantly. A black hole curves space with such intensity that paths collapse toward the center. Light that approaches too closely loses access to every path that leads away. Cross a certain boundary, and all possible futures lead inward. Light is still free, but choice has been removed. That is what makes this concept so astonishing. Light is free. Gravity removes freedom by shaping possibility. Gravity does not pull. Gravity removes escape paths. When we look at a black hole image, particularly the bright ring surrounding the circular shadow of the event horizon, we are not seeing the black hole. We are witnessing the obedience of light to geometry. The bright ring is not matter. It is not plasma. It is not a surface. It is the photon sphere, a region where space has curved so precisely that light circles endlessly. Light does not curve. Light follows straightness. Space curves. Straightness loops. There is no contact, no interaction, no force. Gravity touches space. Light touches space. And space is the mediator. Far from a black hole, space-time is ordinary. You might pass through it and feel nothing unusual. But space-time is not the same everywhere. A photon traveling past a massive galaxy cluster does not know the difference. It follows the straightest path through curved space. To us, that path appears bent. We observe gravitational lensing, the universe bending the path of distant light, so that we see galaxies multiple times or in distorted arcs. We see a single galaxy appear in 4 mirrored images around a foreground galaxy. We see distant objects magnified because space bends like a lens. Yet nothing touches the light. The galaxy cluster does not act on the photon. The cluster shapes space. The photon obeys geometry. This means something profound. If we want to bend light, we do not need to touch the photon. We need to reshape the universe. Imagine space as a river. Light floats on that river. If the river flows straight, light travels straight. If the river curves, light follows the curve. The photon does not need paddles. It does not steer. The motion of space becomes the motion of light. And yet, this raises a question so bold that for a long time, no one dared to ask it aloud. If mass curves, space-time, and light follows the curvature of space-time, then could we ever shape space-time ourselves? Could we rearrange gravity? Could we redirect light by engineering the fabric of the universe? We know that stars, planets, and black holes distort space. We have seen the proof in gravitational lensing. We have recorded gravitational waves. We have measured time dilation. Space is not rigid. It bends, it stretches, it vibrates. If the universe allows stars to bend space-time, could we do the same? At first, the idea sounds impossible. To curve space as a planet curves space, we would need mass, a planet-sized object. To curve space as a star curves, we would need the mass of a star. To bend space enough to trap light, we would need mass compressed so tightly that space-time cannot help but fold inward. That level of curvature produces a black hole. We cannot achieve that. Our technology is far too small, too weak, too limited. But gravity is not the only thing that curves space. Energy curves space too. Pressure curves space. Fields curve space. Even pure radiation curves space. Anything with energy influences geometry. The universe does not care whether the source is mass or energy. Mass and energy are two forms of the same quantity. This equivalence lies at the core of physics. The shape of reality is determined by the distribution of energy. We do not need to touch the photon. If we can change the structure of space-time, the photon will follow. This realization pushes physics to the edge of imagination. If we learn how to manipulate space-time, we could bend light without touching it. If we learn to compress energy into exotic configurations, we could create artificial curvature. A civilization advanced beyond our own might not use mirrors or lenses. They might shape light by shaping reality. Within Earth laboratories, we have already bent space-time. We have watched tiny frame-dragging effects around our planet from rapidly spinning satellites. We have detected gravitational waves created when two black holes collided in deep space and sent ripples through space-time itself. We have measured time passing at different speeds for clocks placed at different altitudes. These experiments are small, but they prove the same truth. Gravity curves space, but we are still only observers. The universe curves space by mass. We curve it only by witnessing. The deeper truth is stranger. Gravity does not interact with light. Gravity interacts with the geometry light travels through. The photon does not fight the curve. The photon reveals the curve. This is why gravity is silent. It reaches everything without touching anything. It shapes the motion of matter without pushing it. It shapes the path of light without pulling it. Gravity sculpts the world and leaves no fingerprints. The photon teaches us that the universe is not built from forces acting on objects. The universe is built from geometry guiding motion. And slowly we begin to understand. We do not travel through space-time. Space-time travels through us. For countless generations we have shaped matter. We carve stone, we bend metal, we ignite fuel, we split atoms. We have reached the point where we can manipulate the smallest particles of matter we understand. But we have never shaped space. We have never held gravity in our hands. We have only felt it beneath our feet and watched it direct the dance of the cosmos. We see its fingerprints on stars and galaxies. We feel its pull, though pull is not truly what gravity is. Yet the question lingers in the quiet of scientific ambition. If gravity bends light by shaping space-time, could a civilization ever do the same? To bend light, we do not need to touch the photon. We only need to alter the geometry through which the photon travels. In theory, this is simple. In reality, it may be the most difficult task imaginable. Our first insight into shaping space-time came from Einstein. His equations of general relativity reveal that mass and energy curve space. Space-time is not static. It is not rigid. It bends. It stretches. It ripples. To curve space-time more intensely, we need more mass or more energy. That is why planets curve space a little, stars curve space significantly, and black holes curve space beyond our comprehension. If we want to bend light with gravity, we must influence space-time. The question becomes, how? The most familiar method would be to use mass. If we piled enough mass into one location, we could curve space-time. But here, the limits crush our ambitions. Even an object as large as Earth barely bends space-time. The curvature is enough to hold Earth's moon, but nowhere near enough to trap or orbit light. To bend a photon into noticeable curvature, we would need something with the mass of a star. To orbit light, we would need something with the mass of a black hole. And to trap it absolutely, we would need to compress that mass into a singularity. Mass is not a practical tool for engineering space-time. If we are to bend light artificially, we must look beyond ordinary mass. The second tool we possess is energy. The famous equivalence that mass and energy are two forms of the same cosmic currency means that energy also warps space-time. Radiation has weight, fields have weight, pressure has weight. A beam of concentrated energy could curve space, yet the amount required is beyond anything our machines can produce. It would take more energy than the output of all human civilization over its entire history just to bend space by a trace. We are not ready to sculpt space-time with raw power. But there is a third idea. The most daring concept humans have ever proposed. It appeared not in a laboratory, but in the equations of a theoretical physicist named Miguel Alcubierre. He imagined a way to travel faster than light without ever violating the rule that nothing can exceed the speed of light. The idea is not to move through space-time faster than light. The idea is to move space-time itself. In his proposal, space-time behind a spacecraft expands, while space-time in front compresses. The craft remains stationary within a calm bubble of flat space, while space-time moves around it. No law of physics forbids the stretching of space-time. The universe has done it before. In the early moments of the cosmos, space expanded faster than light could travel. So Alcubierre asked a bold question. If the universe has done it, why can we not do it? His equations produced a startling result. If you expand space-time behind a spacecraft and compress it ahead, the craft could ride that wave and arrive at its destination quicker than any photon traveling outside the bubble. In this scenario, light does not beat the ship changes the playing field. But there was a problem. The math required negative energy, not absence of energy less than zero. Ordinary mass cannot produce negative curvature. Ordinary fields cannot produce it either. The Alcubierre bubble needs space-time to bend in a direction not created by positive mass. It requires exotic matter, something that behaves opposite to everything we have ever held or seen. Negative energy is not fiction. We have seen hints of it in quantum physics, in tiny vacuum fluctuations, in effects such as the Casimir force, where empty space between two mirrors behaves strangely. But these effects are microscopic, fleeting, weak, nothing close to the magnitude needed to shape space-time. We know exotic energy must exist because space-time itself shows behavior that cannot be explained with positive energy alone. The expansion of the universe today is accelerating, driven by something we call dark energy. Dark energy acts with negative pressure. It stretches space-time outward. It could be the key to bending space-time. But we cannot control it. We cannot store it. We cannot produce it. Not yet. There is another subtle effect that hints at shaping space-time. Rotating massive bodies twist space-time around them. This is not a theory. We have measured it. Satellites orbiting Earth detect tiny frame-dragging effects. Gravity Probe B confirmed that Earth drags space-time as it spins. The effect is unbelievably small, but it proves that rotation plus mass reshapes geometry. If you spin something large enough, fast enough, space-time would twist in a noticeable swirl around it. Imagine a machine built not from mirrors and lenses, but from mass and rotation, a device that could gently curve space-time. It would not touch light. It would change space, and light would obey. Yet even here, we confront limits. The amount of rotation required to produce any significant effect would tear matter apart. Nothing can spin that fast and remain intact. Only a black hole can spin near the ultimate limit. We also know from the detection of gravitational waves that mass in motion alters space-time. When two massive black holes collide, they send ripples outward, stretching and compressing space like waves across a pond. We have measured these distortions from billions of light-years away, using enormous lasers so precise that they can detect changes smaller than a fraction of a proton. These gravitational waves prove that space-time can be disturbed, but again, the disturbance is caused by the collision of impossible masses. Nothing we can build can match that scale. The universe curves space. We only observe, at least for now. We have not yet reached the age where engineering space-time is possible, but the path is visible. The first step was recognizing that gravity is geometry. The second step will be discovering how to produce exotic energy. The third step will be shaping geometry intentionally. One day, perhaps far in the future, shaping space-time may become a tool. Light may be directed not by mirrors, but by curvature. Telescopes may bend space instead of glass. Information could be guided through space-time itself. Imagine focusing starlight without a lens. Imagine routing photons by sculpting the universe. Imagine opening a corridor in space-time so that light travels along a path that never existed before. A civilization that can shape space-time does not bend light. It bends reality. For now, we look at black holes and stars with wonder, because they are the great space-time sculptors. They bend light effortlessly. They direct the motion of galaxies by their presence. Their power is silent. Their control is absolute. We stand at the beginning of knowledge. We have discovered the rules, but not yet mastered the tools. The universe shows us what is possible. It bends space. It bends light. It traps photons without touching them. All we can do is watch and learn. But inside this knowledge is a promise. If gravity bends light by shaping space-time, then mastering gravity is mastering the architecture of the universe. We do not bend light. We bend the road it travels. There is a point in the universe where understanding breaks, where math that predicts the motion of galaxies and the orbit of planets becomes speechless, where time and space collapse into something that does not resemble anything our minds can hold. We call that place the Singularity. It is the center of a black hole, the deepest consequence of gravity, and the end of every path that light or matter can take once the event horizon has been crossed. To reach the Singularity, we must first understand what happens to space-time when mass collapses. Consider a star many times more massive than our Sun. For millions of years it burns through nuclear fuel, fusing atoms into heavier ones, generating pressure that pushes outward. That outward pressure fights against gravity. Gravity pushes inward, pressure pushes outward. This balance holds the star together, but eventually the fuel runs out. The outward push fades. Gravity does not fade. The core collapses. It does not simply fall. It implodes. The collapse is so total that atoms are crushed. Electrons merge with protons. Matter becomes more dense than anything we can imagine. If the mass is great enough, even the resistance of the densest matter cannot hold. Nothing remains to oppose gravity. The collapse continues beyond the limit of pressure. The collapse continues beyond the structure of matter. It continues until space-time curves so steeply that not even light can escape. When that boundary forms, we call it the event horizon. The event horizon is not a surface, it is a one-way edge, a point of no return. Outside it, futures still branch. Inside it, all futures end in one place. Cross the event horizon, and direction loses meaning. The very geometry of space-time changes. Moving inward becomes inevitable, not because gravity pulls, but because there are no longer paths that lead outward. Inside the event horizon, space and time exchange roles. Time becomes the inward direction. Moving deeper is not a choice. It is the progression of time itself. When something falls, no matter what it does, it is moving into its own future, and that future ends at the Singularity. The Singularity is the moment when curvature becomes infinite, not infinite in size, infinite in density. Space-time collapses into a point where all distances shrink to zero. The mass that once held the shape of a star now occupies a location with no width, no volume, no extension. Everything that falls in is carried toward a place where geometry ends. We are left with questions so enormous that even physics hesitates. Does matter survive inside the Singularity? Or does the concept of matter stop making sense? Does mass continue to exist? Or does mass lose meaning when space ceases to exist? The mathematics of general relativity offers only one answer. The equations break. Not because reality stops, but because our understanding does. A singularity is not a physical object. It is the failure of our map. When a thing becomes infinitely dense, space-time becomes infinitely curved. Every path leads inward. There are no straight lines left. There is no future outside the singularity. This is not destruction in the way we imagine. It is inevitability written into the fabric of time. If you could fall inside, your experience would be strange. You would not feel falling. You would feel motion but no resistance. Everything around you would appear normal at first. The event horizon has no texture, no heat, no signal. You would not notice crossing it. But once inside, you would see the universe behind you becoming smaller and smaller. Light from the outside world would stretch, redden, fade. Not because it weakened, but because space-time stretched it. Closer to the singularity, you would not see space. You would see time. All directions would point inward. Forward would become synonymous with falling. Your body, stretched by tidal forces, would experience a widening difference between the gravitational pull on your head and the pull on your feet. Near the singularity, that difference becomes unbearable. The forces grow beyond any material strength. Matter tears, cells tear, molecules tear, atoms stretch. Eventually, even the structure of subatomic particles surrenders. Physics becomes hushed and uncertain. This extreme stretching is not a side effect. It is the geometry asserting itself. Inside a black hole, motion is not movement, it is destiny. And yet, while this journey sounds catastrophic, the singularity is more mysterious than violent. It is where our understanding of reality ends. General relativity describes gravity as the curvature of space-time. Quantum mechanics describes particles and energy at the smallest scales. Near the singularity, both theories apply. Both theories contradict. We do not possess a single framework that explains what happens. The singularity demands a theory of quantum gravity, yet we do not have it. String theory suggests that particles are vibrating strands of energy, and that space may have more dimensions than the three we see. But string theory lives in equations, not experiments. Loop quantum gravity proposes that space itself is made of discrete chunks, that distance is quantized. If that is true, then perhaps the singularity is not infinitely dense. Perhaps the collapse halts at the smallest possible unit of space. In that case, the singularity is an illusion, a misunderstanding created by math that is incomplete. Another idea emerges from ADS-CFT, a bold framework that claims space-time may not be fundamental. It may be created from the relationships between quantum particles. If that is true, the singularity may represent a place where the rules that create space-time stop functioning. Not because matter is destroyed, but because the fabric that expresses space is no longer defined. Other physicists suggest something even stranger. Information falling into a black hole might be preserved in the curvature of space-time at the event horizon. Perhaps the singularity never receives information at all. Perhaps the event horizon encodes it. A black hole may be not a devourer, but a vault. We do not know. Every time we approach the singularity with our equations, space dissolves, time collapses, and meaning dissolves. We understand the path toward the singularity perfectly. We do not understand the destination. The singularity is a frontier. What we can say with certainty is this: the singularity is the ultimate expression of curved space-time. Light cannot escape not because it is trapped by force, but because the geometry erases every path that leads away. Matter does not fall toward the center. Time forces it to arrive. In the singularity, space does not exist. There is only time compressed to its end. Everything that crosses the event horizon ends there. Not because it stops, because space-time stops. Light is freedom. Light does not rest, does not slow, does not change its mind. A photon born at the beginning of the universe could travel for billions of years and never age. It would pass through galaxies, weave between stars, slip through empty voids without once feeling delayed or altered. For light, movement is existence. Distance and time collapse into a single act. There is no hesitation. There is no experience of motion. There is only arrival. Yet in the presence of gravity, something extraordinary happens. Light, the purest expression of freedom in the universe, becomes guided, not held, not pulled, guided. It obeys geometry. It follows the shape of space-time. And if space-time curves deeply enough, light can be trapped forever. The trap is not built from force. It is built from shape. From the surface of Earth, gravity feels like a pull. We drop a ball and it falls. We leap and return to the ground. We assume that we are being pulled downward. But gravity is not a pull. It is the bending of space. What appears to be force is simply geometry expressing itself. We are not pushed down by gravity. We are pushed up by the ground, resisting the path that space-time has chosen. Light feels none of this. Light never resists. It simply follows. When mass is small, the curvature is small. Light passes with barely a whisper of change. When mass is immense, curvature deepens. Light bends, it arcs, it obeys the map that space-time provides. When mass is overwhelming and concentrated into the core of a black hole, curvature becomes destiny. Paths collapse, choice disappears. Light cannot outrun geometry. We tend to imagine that black holes swallow light like mouths consuming matter. But black holes do not reach. They do not grasp. Nothing inside them pulls outward. Instead, space-time collapses inward so completely that every possible path leads to the center. Gravity never touches light. Space touches light. Space shapes the road, and the photon walks it. Freedom is not the absence of barriers. Freedom is the number of available paths. Light, when far from massive objects, has infinite futures. It can travel in every direction, but as light approaches a black hole, the number of futures shrinks. At the photon sphere, there are only two: escape or fall. At the event horizon, there is only one: fall. Inside, there are no paths at all, only the singularity. Light does not lose a battle. The battleground disappears. Across the universe, gravitational lensing reveals the same truth. Galaxies far away shine light toward us. Between them and us lies another cluster of mass. The space around that mass curves. Light follows the curve. To our eyes, the galaxy appears stretched, magnified, split into multiple images. The effect seems magical. The explanation is simple. The light did not bend. Space bent. Light took the straightest path available. We misunderstood what straight meant. Everything we know about black holes comes from light that almost escaped them, not from the light that fell inward. That light is gone from our universe. But some photons skim the event horizon and break free. They orbit for a moment at the photon sphere, then escape. They travel across endless darkness. They arrive at telescopes on Earth. They bring information written not in language, but in trajectory. A photon that orbits a black hole before escaping carries knowledge of the curvature that shaped its path. It becomes a messenger of the invisible. When the Event Horizon Telescope produced the image of a black hole surrounded by a glowing ring, it was not showing us the hole. It was showing the path light carved as it escaped captivity. That ring is the signature of space-time, not matter, not energy, geometry. Light reveals the shape of the universe because light follows that shape without resistance. When we observe gravitational lensing, when we see the phantom images of distant galaxies, when the silhouette of a black hole appears as a circular void surrounded by a ring of fire, we are witnessing the obedience of photons to geometry. Light exposes the architecture of space-time. It is the paint that reveals the invisible sculpture. And that sculpture contains more than stars and planets. It contains time itself. Time flows differently in curved space-time. Near massive objects, time slows. Clocks tick slightly slower on the surface of Earth than clocks in orbit. We have measured this. It is not theory, it is reality. When astronauts travel, they age differently from those who remain on Earth, though the difference is small. The greater the mass, the stronger the curvature, the slower time moves. Near a black hole, time slows so dramatically that the universe outside could age billions of years while a moment passes near the event horizon. For light, something even stranger happens. Light experiences no time. A photon emitted from a star and absorbed by your eye experiences both events as one. There is no middle, there is no journey. But despite having no sense of time, light still reveals how time behaves. The stretching of light as it escapes gravity is proof that time slows near massive objects. The redshift is the footprint of time dilation. Light shows us time by losing energy to escape it. If space-time were flat and uncurved, light would travel the same way everywhere. The universe would be a straight corridor. But space is not flat. It curves, it expands, it evolves. Galaxies drift apart not because they move, but because space-time stretches between them. On the largest scales, reality is not made from objects, but from relationships. Not from things, but from distances. Light is the thread that reveals those distances. The universe is a map, and light is the pen that draws it. In black holes, we see the limits of our understanding. The singularity is a place where geometry collapses. Not because something explodes or tears, but because the rules that define distance and direction stop making sense. General relativity predicts the singularity. Quantum mechanics refuses to describe it. Somewhere between those two theories lies the truth. Light leads us there, but light cannot return. At the singularity, distance collapses to zero. Time collapses to an end. The laws that describe motion stop. The idea of place becomes meaningless. It is not that the singularity destroys information. It is that space-time itself ends. Our equations crumble because the framework they depend on vanishes. Space is not a backdrop. Space is the actor. Space shapes motion. Space shapes time. Space shapes possibility. And gravity is simply the bending of that stage. Light does not resist. Light reveals. Every time a photon bends, loops, or falls, it teaches us something. It teaches us that the universe is not what we see, but the geometry that shapes what we see. Black holes show us the extreme of that geometry. They trap light without touching it. They end paths without force. They shape reality through shape itself. Light shows us how gravity works. Gravity shows us how space-time works. Black holes show us the limit of both. The journey of light across the universe is not a story of motion, but a story of possibility. Light moves freely. Gravity moves space. And light can never outrun the shape of space.